Okay, so we're trying to figure out the sample size to get a particular margin of error. So we're going to use our margin of error formula, but we know what it's equal to. So we were talking just a minute ago, we need to change that percent to a decimal. So we move the decimal place 2 places. So we've got 0.075 is equal to 1 over the square root of n. I'm going to leave the plus or minus out of the equation right now because we don't need it right now. Now, there are a couple of different ways that we can handle this equation, but let's think back to when we were reviewing trig. Whenever our variable was in the denominator, what happened? These two things switch places because we would multiply to get the variable out of the denominator, and then to get the variable by itself, we've got to turn around and divide by that 0.075. What's the opposite of square rooting something? Squaring. So we're going to square both sides. So our sample size is equal to 1 over 0.075 squared. So we go to our calculator, put it in just like we see it. And we are talking about sample size, so we're going to assume we're talking about people or animals. We're talking about something, and we're not going to talk about 7/10 of one of those, so let's just round that to the nearest whole number. Round it up. Actually, always round it up, okay? Always round it up, because even if we had gotten 177.2, okay, if we gotten 177.2, that would not give us, if we, that's our sample size, 177. Okay, if I do 1 over the square root of 177, I do get 7.5. That one is enough. But we just want to round up. Okay, you want to round up every time, because sometimes if you go down, it won't be enough. Okay, so if we go up to 178, we get 7.495. That would round up to 7.5%. Okay, so 178 is our answer here. Now, so that you don't have to reproduce that every single time, let's come up with our formula right here. Sample size is equal to 1 over the margin of error squared. And of course, make sure you convert to decimal form, because it will be in a percent, so you need to express that as a decimal when you plug that into that formula. It's just the opposite of the margin of error formula, or the inverse, actually, would be the better term there. It's the inverse of the margin of error formula. It gives you the sample size when you know the margin of error. Okay?